sodium acetate trihydrate. See the trihydrate? Trihydrate, see the 3 water molecules bonded to the sodium acetate? When you heat it up, the 3 water molecules come out into solution. And then dissolve the sodium acetate. So it's kind of funny, the formula dissolves itself when you add heat. Now this should be a supersaturated solution, and we can have a lot of fun with supersaturated solutions, but they're very, very fussy. So what I have to do is I have to cool this very carefully. No one can jostle the counter. I'm going to cover this with a watch glass so that no dust particles fall in there. Okay, so we're going to remove this from the heat and we're going to let it cool down. And I didn't bring a watch glass home, so I'm going to let it cool with a stopper loosely placed on top of it. So this is now a supersaturated solution of sodium acetate trihydrate, and I'm going to allow it to cool without any interruption. I always think of supersaturated solutions as very agitated people, and you accidentally bump into them and they just freak out on you. You'll see in a minute why I say that. Okay, so we have another supersaturated solution, and I'm going to drop a seed crystal into here. Look at the patterns. Now feel it. Ooh. It's shockingly exothermic, huh?
Very warm.
All right, so I'm gonna melt it and do it a 3rd time. All right, what we're gonna try to do now is pour this supersaturated solution into here and pray it doesn't get agitated too much and crystallize, and it didn't. And then we're going to drop a crystal right into the middle of it. Now remember, this is our supersaturated solution of sodium acetate trihydrate. Now that is satisfying, beautiful.
Do it.
It's trying, it's going. It's like those sand castle drip castles.
Just Dad, Mom and I have been saying the same things.
Quarantine life.
It's a problem.
This is the tallest one I've ever made. Ta-da!
How'd you do that?
That is a supersaturated solution of sodium acetate. If you touch it, don't touch it, it's chemical, it's warm.
I want to touch it.
Explodes.
I have safety glasses on, not really.
Not really. Is it warm? You gonna wash your hands now?
Yeah.
I call this experiment Lot's wife. All right, guys, now you've seen all the different ways we can play with a supersaturated solution. All day long, I've been doing this, reheating it. So that's it. That's the tallest lots of Wi-Fi I ever got. So you just saw a supersaturated solution of sodium acetate. So let's define some terms. First of all, what exactly is solubility? Well, if you've made iced tea before, you know that sugar dissolves well into your iced tea mixture if you have heated it up. But you also know if you're at a restaurant and you ask for sweet tea and the waitress brings you unsweet tea and some packets of sugar, you feel kind of irritable. Why? Because you know that that sugar is not going to dissolve into the cold iced tea like it would have if they would have added the sugar when it was hot. So why does this happen? So let's first of all define what the term solubility actually means. Solubility is the quantity that can dissolve in a certain quantity of water. We normally report solubility as the grams of substance per milliliter of water. Sometimes you may have tried to make rock candy as a child, and remember you took your hot water and you kept dumping sugar in and dumping sugar in and dumping sugar in. Then you used all of the sugar in your house and still more sugar wanted to dissolve in. Water can contain a whole bunch of sugar if that water is hot. And I learned that the hard way. My mom came home and I'd used up all the sugar, and I may or may not have gotten into trouble for that. But I was sciencing as a 10-year-old. And then, you know, you put a pencil across the top and you dangle a string in there, and then you leave it and you come back, and then you get these sugar crystals that form, and they're very pretty, and then you eat it and it's like rock candy. But generally you reach an upper limit of solubility, and it doesn't then matter how high you heat it or how hard you stir it, you've reached that substance's maximum solubility. So let's look at this. This is a classic solubility curve for sodium acetate. You'll notice that on the y-axis, I've got the solubility grams per 100 grams of water. Remember, the density of water is 1, so that could also be grams of my substance per 100 mils of water. And this is my temperature. So what we notice is we have this line here. And this line here is called a solubility curve. And when this line is met, we have a saturated solution. What does that mean? Let's pick a point. Let's pick a point right here at 50 and 25. What does that mean? That means at 25 degrees Celsius, I can have 50 grams of sodium acetate dissolved in 100 grams or 100 mils of water. If I had that much dissolved in there, it would be considered unsaturated. That would mean that more could be dissolved in. In fact, at 25 degrees, what is the maximum amount of sodium acetate I can have dissolved in? Let's see. At 25 degrees Celsius, I can have almost 90 grams of sodium acetate dissolved in 100 mils of water. So let's take another reading. What if I ask you what's the maximum amount that can dissolve at 50 degrees Celsius? Well, here's my 50 degrees Celsius line. At 50 degrees Celsius, the maximum I could dissolve is a little over 100 grams of sodium acetate per 100 grams of water. That's pretty crazy. And you notice as we heat this up, I increase my solubility. Now, anything along this line is saturated. So what if, for example, I put this on a hot plate, which you saw me do in the video a few minutes ago, and I got it up to 75 degrees Celsius, which I did. And what if at 75 degrees Celsius it is a saturated solution? That would mean that I have approximately 120 grams dissolved in 100 mils of water. Okay, then what did I do? I very, very carefully cooled it down, and something crazy can happen. If I very, very carefully cool it down to room temperature, let's say room temperature was about 23 degrees Celsius, now all of a sudden I have what's called a supersaturated solution. And in the video you just saw, that was all a supersaturated solution. What does that mean? That means that all of a sudden I've got this much more crystals sitting in solution than ordinarily would be. And in this case, I would have from there to about there approximately 10, 20, 30, nearly 40 grams extra of crystals sitting in solution. And then along I come and I jostle it, or a piece of dust falls in it. Here's my solution, piece of dust or a crystal falls in it, and what happens? Well, from an aerial view, you saw what happens. It crystallizes out into this very, very pretty pattern. Okay? And when it crystallizes out, the amount of crystals that will crystallize out are the amount of crystals that are above this saturated line. So to summarize, below the saturation line, everywhere here is unsaturated, along the line is saturated, and above the line is supersaturated. Now every year I play with sodium acetate, trihydrate, and I try to get as much to dissolve in it and see what kind of crystals I can get to form. This was one year a few years ago. I had a student by the name of David Geller, thank you David, who took this awesome picture of me pouring onto an overhead projector, and it made a very pretty Lot's wife, although I must say the Lot's wife that I made today is the highest one that I've ever made. Here's another graph, a solubility graph, and this is of 3 substances. Once again, you have the same axes, grams of solute dissolved in 100 grams of water, and you have temperature on the x-axis. Notice that salt, the line is relatively flat. What does that mean? That means that if you took salt and you were trying to add more salt to water and you kept heating it up thinking it was like sugar, you're not going to get much change. Salt solubility is not affected very much by temperature. That line barely moves. Potassium chloride, however, this green line is slightly affected by temperature. But potassium nitrate, and if we were in school, we would do an experiment with potassium nitrate and make our own solubility curve. Potassium nitrate solubility increases incredibly as we increase temperature, and this red line is our potassium nitrate line. But remember, if you're on the line, if the point you're reading is on the line, then that means it's saturated. If the point you're reading is below the line, then it's unsaturated. And if the point you're reading is above the line, then it's supersaturated. So tomorrow we're going to do a few calculations with these. But I want to finish this off with some of my favorite YouTube videos that I found and on YouTube. This one is the hot ice sodium acetate. This one is by the author Mike Shin. He makes an amazing video. Folks, this is about 10 levels above what I did. And you can search for some really fun ones. Isn't that beautiful? And then there's this one. This is by Dr. Nitro. So folks, all you have to do is go to YouTube, put in hot ice or sodium acetate, and you can see all kinds of wonderful variations of supersaturated solutions.